work? It works. All right. So 6-2 AP Calculus. Today's date is January 5th, 1/5, 2021. Our objective today is to do what, Chris?
Find the general particular solution to differential equations.
There it is. And this is probably the hardest math that people typically do in all of AP Calculus. So just as a preparation. I also want to talk about how this lesson compares to our lesson yesterday. So yesterday, we had a general solution when we had oh my gosh, a slope field. I was almost forgetting the name. I was like, the slope thing where you had the slopes everywhere. Yeah, the slope field, where I said the slope field represents all solutions. Like if you had a quadratic like we had yesterday, it would be a quadratic that would be there. It could be there. It depends on what initial condition. If I have an initial condition that starts there, it's like, oh, well, that's that parabola. If I have an initial condition that's right there, oh, I have that parabola. Like if you put a point anywhere on here, if you have the slope field, that is the general solution for everything. But then there's also the particular solution, which is, hey, if you know the initial condition, like, hey, I know there's just a point on the graph here at, I don't know, let's make up a number, 0, -1, that looks about right. If I know 0, -1 is a point on the graph, then I know it's not all of these parabolas, it's specifically this parabola right there. That's what we're doing today. We're boiling it down into one solution where you guys at the very end of everything will be able to spit out an answer and be like, oh, it's this equation. That's the answer, which sounds easy when you first think about it. It's like, oh, if I know that if it gave me y prime is equal to x, I know that, and then you can take the antiderivative, right? And you can say that's x squared plus c, and I tell you what c is and thing. Maybe c was 1, it's x squared plus 1. The answer is x squared plus 1. That sounds like an easy process, until you realize that I can give you really, really hard forms. I might give you y prime is equal to x, y, or something harder than just one variable. I'm allowed to do that, and that's what AP tests frequently will do. So the general form over here for the general solution is it's anything is equal to anything plus c. There's like, you could have anything. Over here, the only difference is we know c. It's something is equal to something plus, or I don't know, -1 in this case. You'll have a number here. That's the main difference between these two. Okay, so this section that I'm about to do, there's a ton of points on the AP test, and I'll talk about scoring once we start touching on our self-checks. But in terms of all of the free response questions that you'll see on the AP test, this type of question, this category that I'm talking about is like 6 to 8 out of the 9 points. It's a ton of points for the question. So just know that going into it. Yeah, I can't speak. So first, separate. Second, integrate. Third, evaluate. Fourth, isolate. They all kind of rhyme. Hopefully you can memorize those, because that is what would theoretically be on our speed sheet. Separate, integrate, evaluate, isolate. When do you do that? You do that whenever you hear the words find a particular solution. Like sometimes we're doing general today, but I think particular solutions, maybe I should change the title of this. I'm going to say particular here. Particular. Whenever you see the word particular, that means that you're going to be doing separate, integrate, evaluate, isolate. And isolate, there's an asterisk connected to that. Let's go ahead and do that right now before I forget. All right, so let's do these steps. First, separate. Separate, you need a fraction set equal to a fraction. And hey, we have that over here. So we need fraction equal to a fraction. So we're good so far. It's already set up for us. If we didn't have a fraction, you'd make it divided by 1 or something. Always have a fraction. So if it was equal to like x squared, then you say it's x squared over 1. That's a fraction. And then you would cross multiply to solve. So the next step would be cross multiply. And then you want to separate your x and your y. That's what I mean by separate. You want x's on the right-hand side, the y's on the left-hand side. And it doesn't matter which goes on which side. As long as they're on each side, they're not touching each other, the p's and the carrots don't touch, you're good. So last step, separate. Separate. x and y. They have to be on each side. So let's do that. So let's cross multiply. So if I multiply y times dy, I'll get, I guess I'll have to move down here because I don't have enough room. So I'll say y dy. Okay, is equal to, cross multiply the other direction, x squared times dx is x squared dx. I mean, there's not a lot of hard math here. You just squish symbols together. And separate x and y. This is just a step to verify, hey, are all the y's on one side, all the x's on the other? And check it out. Yeah, y dy, all the y's are on one side, x dx, all the x's are on the other. We're done. Pat ourselves on the back. That was a nice and easy problem. Obviously, I'll be making these harder on the homework. If they're not on the same side, like maybe this was an x and this was a y, then I'd have to divide by y. I could say, oh, divide by that y to get it over on the other side, divide both sides. But I'll show you that in a bit. So, and that's kind of what I want to say here. So if you have y dx is equal to x dy, where they're not the same after you cross multiplied, how do you do the separation of x and y? Just divide by y. Like divide both sides by y, divide both sides by x. I'll say just divide. Keyword here being divide. Don't make the mistake of thinking, oh, I could just subtract y from both sides. No, y is being multiplied by dy. So the inverse operation of multiply by y is divide by y. Don't subtract. Okay, so far so good. We've done step 1 of the 4. We have separated our variables. And just by doing that, we might be up to 2 or 3 points. Okay, actually, we might just be to 2. So integrate. So don't forget your cake. Don't forget your plus c. Let's integrate both sides. You just write the integral. So I'm going to rewrite this equation, but with an integral on the left and integral on the right. So integral of the same thing, y dy is equal to the integral of x squared dx. And I actually have to do the integration. So this is where I finally need some help. Let's get some people to help me. Fiona, the integral of y is what?
Y prime?
Sorry, say that a little bit louder.
Is it y prime?
Oh, so it used to be y to the power of 1. It goes up a power, right?
Y squared
Yep, and then divide down
by 2.
over 2. Perfect. And we'll add the plus c to one side or the other. We could add it to this left-hand side, but typically we add it to the right-hand side. So I'll make Andrea remember the plus c. So you solved the left-hand side. Good job. Let's give this to Andrea now. Antiderivative of x squared. How do I take the integral?
X cubed over 3
And then you have to remember the cake.
plus c.
Plus c, yeah. You only need one of these plus c's. Don't have them on both sides because then they'll cancel out. And you need to have that concept of integration somewhere. And typically we put it on the right-hand side. Why? Because once we do our isolating, once we get y by itself, it's nice to have y equals a bunch of junk on the right-hand side. But it doesn't matter. You'll get the right answer either way if you put the plus c on the left-hand side instead of the right. Cool, so we have done step 2. We have separated, we got x's and y's on each side. We've integrated, we now got rid of the dy, we got rid of the dx. And now the key step here, evaluate. And if you don't know the word evaluate, that's the synonymous with just saying plug in. Plug in your initial condition. So our initial conditions up here, the initial condition is that when I plug in 3 for x, again, that's x, then I get the y coordinate 1. So the y is 1, the x is 3. So I look at that integration from step 2 and I say, okay, well, the x right here is 3. So I come down here and rewrite that as a 3 cubed over 3 plus c. And then that's equal to, and then the y we know is 1. So I can rewrite that as 1 quantity squared over 2. All right, now this is where I have to make the distinction between what we do in my class versus what we do on the AP test. In my class, it's harder than the AP test because I want you to simplify both sides. I want you to solve for C. In order to get your point on my test, you need to actually find a value of C. Just doing this and leaving it gross and unsolved, that's not okay. Practice solving for C. So we're kind of running out of room here. Let's move maybe over here to the left-hand side-ish. Okay, well, I have technology. I have technology, so let me just grab this and move it over. But just find some more room. We're going to solve for C. So I'm going to do a little arrow that says we're solving. Okay, so I got have, Chris, help me. What do I have on the left-hand side and the right-hand side now after simplifying?
On the left side, you just have 1/2.
Perfect.
And then on the right side, you have just 9.
9 plus C, yep.
Yeah.
And then Chris, solve for C. What is C?
Hmm. I don't know.
Subtract 9 to both sides, right?
Oh yeah, right.
So 1/2 minus 9 is?
4.5.
9. Not quite. It's so think of 9 minus 1/2 and just make it negative. If I have $9 and I pay you 50 cents, I'm left with how much money?
$8.50.
Yeah, 8.5. It's negative 8.5 because we subtracted a bigger number from a smaller number. Cool. So we have our value of C. Thank you, Chris. We've done step 3, and this is where you usually will stop. You haven't solved everything though. We haven't done the isolating step. Why do you stop here? It's because of the scoring of free response questions. So let me talk about the steps for isolate, and then I'm going to talk about why we don't typically do it. So isolating is a ton of work. For this problem, it's not that hard, but for most problems, it's pretty darn difficult. To isolate, it means get y by itself. So get y by itself. That's what I mean. You've isolated y, you've solved it. Y equals, there's your equation. You have solved this problem. But you don't need this for the AP test. Don't need for AP test. And this is my inner conflict as a teacher is like, mathematically, you should learn these things because it's interesting, and it's useless to say, well, I did 3/4 of the problem and then I'm done. Like mathematically, you should solve all of it. But I realize that you'll spend probably 5 minutes doing the first 3 steps and then another 10 minutes doing step 4. And step 4 is only worth 1 point, so why bother? I'm gamifying this. It just requires too much work. So this requires lots of work for not very many points. So for not very many points, for less points, or for little points. And let's talk about the scoring now. So each free response question is worth 9 points. So let's start off. I can't spell, dear gosh. Each FRQ, free response question, is 9 points. Yes, eventually you'll learn about how many problems there are and such, but for each of these problems, you need to be getting a 3. Or sorry, you need 3 out of 9 points. 3 out of 9 points on average to get a 3 on the actual overall AP test. On AP test. And by the way, if you get a 3 on the AP test, a 3 on the AP test, as you all have known because you've taken AP classes before, means you get credit. This means you get credit. College credit, I should say, for most universities. And even if the university says you don't get credit, it makes you retake it, at least having a passing score helps you get into that college. Although if you're a senior, maybe that time has already passed, whatever. But usually a 3 on the AP test means you get college level credit you're more units ahead. And at least for my experience when I went to UC Davis, because I had more units, the way that you choose your classes is they say, if you have more units, you get to choose your classes earlier. So that's if you're a senior or a fourth year, you've taken a lot of units, you get to take your classes before the first years. But if you have a bunch of AP credits and you come into school, you get to choose your classes ahead of the rest of your classmates, which is kind of cool. It's like, ooh, I want to take that winemaking class because I get credits for that. So in terms of this problem, this type of problem where you're solving for a particular solution, you, by step 3, by evaluate step, once you're done with step 3, so by step 3, you'll have 6 to 7 points, which is more than enough to get a 5 on the AP test. And that's why I don't want people doing step 4 unless they're overachievers, which I know some of you are. But let me just say, my expectation is that everyone finishes step 3. If you want to go above and beyond and you have extra time on the test, go ahead and do step 4. I'll teach it, but my expectation is that you're not going to do it unless you really, really want to. So let's do an example in the back. Are there any questions before I move on? I just want everyone to know that this does hurt my soul a little bit that I'm not teaching math and teaching you how to gamify it. And that's the point of AP Calculus. I'm giving you college level credit for less work than a college level class. All right, example 1. There it is. Find the general solution with the initial condition y of 1 is equal to 2. And I really should rewrite these problems because that's not how they look on the AP test. I really should say find the particular solution, because this keyword particular, that means that you're going to be doing this process. So I need to change that for next year. Find the particular solution when that is a point on the solution. Yeah, because that's the giveaway. When do you do separate, integrate, isolate, or I missed one, evaluate, isolate? When do you do those 4 steps? It's whenever you see this word particular solution. So maybe star that, maybe underline it, circle it, highlight it, do something to let you know. If you see the words particular solution, or if you see something of this form where they're giving you a y prime is equal to something kind of difficult, that means you're doing these 4 steps. So here we go. We're gonna write them all out. You don't have to write these steps, but I am, just so that we can stay organized. So step number 1 is separate. Separate. All right. You've seen me do this before. You helped me do the last example. This is your first we do type of question though. What do? We'll give it to Andrea.
You cross multiply?
Perfect. So I usually like having my dy on the left-hand side. So I'm gonna do that one first. I'm gonna do x dy. So I have x dy on the left-hand side. On the right-hand side, we'll have 3y dx. 3y dx. And again, it doesn't matter which side you choose. You're not done, Andrea, though, because that's not separated yet. You have to finish all of step 1.
Do you divide?
Yeah, what are we going to divide both sides by?
X and Y?
Yeah, so if I divide by x on both sides, that moves the x to the right-hand side. And if I divide by y on both sides, so divide by y, that moves the y to the left-hand side. So what is our new equation after we divide by xy on both sides?
Y dy and 3x dx?
Really close. So you're actually doing 1 over y and 1 over x. So you'll have 1 over y dy on the left-hand side.
And then 3 over x dx?
Perfect. Yeah, 3 over x dx. All right. Good job, Andrea. You have officially completed step number 1. We have separated. Let's move on to step number 2. We'll give that to Fiona. Step number 2, do you remember what that step is, Fiona?
Integrate.
Integrate. We'll write down integrate. All right. I'll do the hard part by drawing these symbols for you. integrate 1 over y dy is equal to the integral of 3 over x dx. And maybe I can move this word particular underneath. So it doesn't take very much room to actually do the integration here. All right, Fiona, integrate that left-hand side. Maybe we'll give, no, you can do both sides. They're basically the same.
Is it y? And then like you add one, so it's y to the 0 over 0.
Yep, and then divide by 0, and oh, you can't divide by 0, which means
You use like natural log.
there it is, yeah.
Value.
Yes, and you remember that absolute value as well. So we have natural log, absolute value of y. Perfect. What about the right-hand side?
Would it be natural log absolute value of 3x?
Oh, not quite. So 3 is kind of like a constant that you can factor out. So I can just write 3 times natural log of that same variable x, right? You're not done because
Plus c.
plus c. And this is kind of a fun fact. Just by writing plus c on like 100% of the cases that I've seen, you get a whole point just by writing plus c. And I'm not even joking. Remember how I said you need 3 points in order to like get a passing score on the AP test? Writing plus c gives you a whole one of those 3 points. Don't forget it. It is super, super important. We're on to steps number 3. Chris, what is step 3?
Evaluate.
There it is, evaluate. All right, so we have Fiona's natural logs equation. How are you gonna use this fact that y of 1 is equal to 2 to plug things into Fiona's equation?
Be natural log of, is it 2? Or would it be 1?
Oh, wait, yeah, you're right. Yeah, so 2 for this one, yeah. Natural log of 2 because y is 2, and then you plug that in. So far, so good, yeah.
Then wouldn't the other one just be 1?
1, yep.
Okay.
Cool. And then I said that you need to solve for C, and you kind of do. When it's this hard, then I'll be like, it's okay. You don't really need to because it is kind of too hard. Just by plugging it in, by writing the fact that this 2 goes here and this 1 goes here, you get another full point on the AP test. And in my class too, I will have specific instructions for, actually, no, I'm going to make it like the AP test for my test. If you see something hard like this, you get your point. If it's something easy where you could definitely solve it, because like an algebra 1 problem, like this is, this is like first week of algebra 1. If it's something easy like this, I'm expecting to solve. If it's something that looks hard like this, don't worry about it. But I will show you, is it tomorrow? I do show you tomorrow how to solve this equation because it is solvable. And it's not that tricky. It's just you have to remember the trick for it. Cool. We've done all 3 of those steps. And again, step 4 is very optional, and I expect you not to do it. All right, on to example number 2. All right, let's switch things up a little bit. Andrea, you did step 1 last time, right? Fiona, you're doing step 1 then.
Separate.
Yep. Separate.
You put negative y over 1 so that you can cross multiply.
Perfect. What do I have after cross multiplying?
Negative, or dy equals negative y dx.
Perfect. Yep.
And then you divide by negative y.
Divide by negative y. Divide by negative y. So our final equation, Fiona, is
1 over negative y dy equals dx.
there it is. Fiona has done all the separating. You can clearly see all the y's are on one side, all the x's are on the other. Perfect. I'm running out of room. Let's move to the right. Step number 2. Chris, you're going to do this one for us.
Okay.
So first of all, what is this step? What is its name?
Integrate.
Yes. Integrate. And again, I'll do that hard part for you. There's our integral symbol, and I'll rewrite Fiona's 1 over negative y dy is equal to the integral of dx. I just drew integrals in front of Fiona's equation. All right, Chris, what do we do? So this negative y can really be factored out if you want to think about it that way. So you really have a negative out here and then just a positive 1 over y. And then if you compare that to how Fiona did step 2 in the last problem, it's basically the same.
Should be negative natural log of y.
Yep, really close. Negative natural log of absolute value of y. Yep, is equal to
It's just x.
x, exactly. Because you want to think there's an imaginary 1 that goes up to power x to the power of 1. So x, and then don't forget your
Plus c.
plus c. Yeah, that's a whole point just by doing that. Nice. All right. Chris has integrated both sides, and we'll give it to Andrea. Do step 3 for us. What is step 3?
Evaluate.
Yep.
Is it just, oh wait, never mind. Negative natural log of 5 equals 3 plus c.
There it is. And because we haven't really learned how to undo natural log to both sides yet, we're done. I mean, we have in pre-calculus, but I don't remember if you remember how to do that. So we'll just leave it there for now. I'll reteach that tomorrow. All right, there it is. Okay, so how's everyone feeling about solving for a particular solution? Just a 5 for objective. How can you find a general particular solution? I should really just say find the particular solution to differential equations. Let me make a few changes. 4 for Fiona,
Like that.
3.5 for Chris, 4 for Andrea. All right, cool, thank you.